go and get recording. So today we're going to be going over Docker networking. Docker provides a flexible and powerful networking model that allows containers to communicate with each other and with external world. By default, Docker containers run in an isolated network, namespaces meaning that they have their own network stack and IP address. However, Docker networking provides several options for connecting containers, enabling various network topologies and communication patterns. So there's three main Docker network drivers that you guys should know. So there's a bridge network driver, default network driver in Docker. It allows containers on the same host to communicate with each other. Limited scalability and lacks cross-host communication. We have overlay network driver, which enables multi-host communication across multiple Docker daemons or Swarm services, achieves network isolation, and provides seamless connectivity between containers in different hosts, suitable for multi-host deployments such as Docker Swarm or a Kubernetes cluster. And then host network driver. Containers use host network static directly. Offers high performance as there is no overhead of virtualization. Reduced network isolation since containers share the same host network as a namespace. And useful for performance critical applications that require direct access to the host network stack. Today we're going to be going over bridge network. I think that one will kind of make the most sense to you guys as our little demonstration we'll go through on the next lesson. So bridge network. The default bridge network is the default network driver in Docker. It allows containers on the same host to communicate with each other using the bridge network. This network driver is easy to set up and provides a basic level of connectivity for containerized applications. So if we wanted to get into, bring up my terminal here, make it smaller. So to list out our networks, we just run Docker network ls. As you can see here, I have quite a few different ones. Most of them are bridge networks. I do have one host network. So we can show the details of bridge network and explain the properties, subnets, IPs, and why containers are in the default network bridge. So if we do Docker network inspect bridge and then pipe to less. Well, that didn't do that, huh? I did. I forgot the T on here. Then you can kind of see, all right, we have our network ID, when it was created, scope, what type of network is. You can see if IPv6 is enabled, our gateway, subnets, just like your standard network. Then it's just Q to exit out of that. So we can also create a bridge network. If you wanted to, go ahead and click that. Then we're doing Docker network create tac driver bridge. So it's going to be a bridge network, and then we're going to name this one Chandra, our Docker _ Chandra _ net. Now, if we do a Docker network ls, we can see we created Docker Chandra net, which is a bridge. Then we can go into host network. So host networking in Docker allows containers to bypass the network isolation provided by the bridge network and instead directly use the host machine's network stack. This can be useful in situations where you want to access services running on the host machine or when you require low-level access to network resources. This command starts a new web server named web server using Nginx image and enables host networking using the tech network host flag. So this should, let's make sure I shouldn't have any containers running right now with named web server. So if I do a Docker PS, that didn't work. Check Nginx working on 480 system. So then we can just go into localhost. But if we do a Docker PS tech A, yep. For whatever reason, I think that's a degraded image. So that one doesn't work, but it did create it. And it's right there. Docker RN. What was it called? Web server.
Justin, why did that Docker container exit? So it's exited 25 seconds ago.
Yeah, I think that was just a bad image. So we could probably try like Nginx tag latest. That'd be my guess, is it was just a bad image. Sometimes that's pretty common, especially like when you're building your own images through like a Docker file, that'll happen quite frequently.
Yeah, that's happened to me before. It usually means that the image is not working.
Yeah,
Right?
so maybe we can try something like this. Doesn't like that one either. Yeah, there might be another Nginx image out there right now with like a specific name, but we can get into that later. Okay, so we could do, let me clear this real quick. Make this terminal a little smaller too. So then we can also do a known or a none network, so where it's not really connected to a network. So we could do with that is now we're running the Docker command tech D. We're just naming an isolated container. Network none, and it's using Alpine Sleep Infinity image. So if we do a Docker PS on there, so that one's running, but it's not in any network. So if we go in, we can just Docker exec into it. And then it's warning us to ping Google. It shouldn't work because we're not connected to any network, right? So we're trying to ping Google and it says bad address, but we know google.com works. So that makes sense to you guys. You need a network to be able to access outside, especially something like a host network. That way you can access things that's like running locally on your computer, things like that. We can also bind the container to a host port on a web container. So we could run the following command to bind the web server container to specific port on the host machine. You know what? That might be why that didn't work the first time. Let's see. It's still there. So if we go to localhost here, I think we'll have, and it was on 8080, I believe. Boom. Now we have Nginx container running, right? 8080. So that's kind of cool. So it's just like deploying any other application with Nginx. Now we're just using Docker containers, so we can have a containerized application deployed the same way. Alrighty. I'll stop the share. We'll resume recording. And here we are. Okay. So multi-container or multi-containers running on a network. Here you will learn how to set up Docker container running on a Postgres database and connect to it with a Python Flask application. The Flask application will use SQL Alchemy to interact with the database. You will explore two options: running the container using the host network and running the container using the bridge network with port mapping to Flask to access the database. So if everyone wants to clone down this repository, I already have, as you can tell, I'm already in it. We're going to be deploying Twoj, and that's a requirement. So make sure that you guys clone that repository down. So what you're going to do is you're going to run Docker network create my network, and so that will create a bridge network, since that's kind of like the default. So I do a Docker network ls.
Sorry, just real quick, we're doing this within the Twoj folder that we pulled down.
Yes, that is correct. So yeah, once you clone it, CD into that directory, or else your Docker file will probably not work unless you adjust it to do so. But that'll make it easiest. So then copy this right here, right? We're just going to make a Docker file, which my Docker file looks like this. But we're not going to build it yet. Also, mine looks a little different right now than what your guys like. If you guys will add in this URI as an environment variable. So the first container that we're going to do is the database container. Does anybody know why we would do that before our web server container? No?
Need a place to put the data.
Yep. Okay. Yep. Need a place to put the data. You are exactly correct. And plus, the image that we're going to build off of needs the URI, that value, in there in that environment variable so that it can connect. So what we can do here is we will do a Docker run tac name Postgres container. So that's the name of the container, right? Here's all the specifics. And we'll go ahead and do that. So you can tell here, we're passing in these environment variables into that container to kind of set it up for us already, kind of automated. So we're already creating the user, we're creating the password, the name, what image we're using, and then created other containers. So if we do a Docker PS, boom, it's running right there. And it's running on port 5432. That's something also to remember. So it is Postgres. So once we have that container, you can take this URI here, which this shouldn't be new to you guys. Maybe just adding it into the Docker file might. But this is where I was saying it's a little bit different. And you're going to paste it in this environment variable right here. So in the M SQL Alchemy or SQL Alchemy database URI equals, and then just make sure it's in single quotations, and just paste that in right there. That should work for you guys. Now what we're going to do is we're going to build the image for the Flask application. So since we already cloned down that repository, right now that we built out that Docker file, we can run a Docker build tact Flask app. So that's what we're going to name it, Flask app. So it's going to go ahead and build out that image. I already built mine out. That's why mine went a little bit faster. And these look a little bit different because they're already cached. But you guys, it might take just a couple seconds longer. And then similarly to starting up that database container or creating that database container, we're going to run it with that same network. So that's like the biggest thing that we went over here is we use tac network, and we're using that network that we created on both, right? Also, in that URI that has the port for that database, the name of that database, user, password, so it's able to connect already because we've already passed in that environment variable. You can also pass that environment variable in and override that Docker file, or even not even have it in your Docker file if you just passed in the command when you're creating this this Flask application now. So we'll go ahead and copy that over. Now we're going to run that container. And boom, now we have this Flask application running in that container. Let's make sure it's still running. Perfect. So now we can see if that container is running, and we can just check if we bounded that mount or that port 8080. So now it should be running on localhost 8080 if everything is correct, which it is. So we can make our Twoges. It's right there. Let's see if these were in the same networks or just the database was in the my network and the Flask application was. They wouldn't be able to communicate and it wouldn't work. Do you guys have any questions?